All right, Brandon Clayton here, the Algebra Guy. Thanks for tuning in. Our discussion today, how to write linear inequality when you're given a graph, table, or a verbal description. All right, let's jump into it. So our TEAK, or our skill that we want to cover here, is write linear inequalities in two variables, given a table of values, a graph, and a verbal description, just as my title suggests. So what is this all about? So we're going to be given, I'm going to start us off with verbal descriptions. Most of the time when you're tested on this, you're going to be given some word problem, and they're going to ask you to write an equation or identify a graph that goes with that. Most of the time, write an equation. So that's what we're going to start with. I'm going to give you a couple of variables, and we're going to write the graphs and equations that go with those. All right, Rosalinda is going to the movies with her friends, and she wants to buy some snacks when she gets there. Each bag of popcorn, P, costs $5, and each bag of candy, C, costs $2. Her mother gives her a $50 bill and tells her to spend no more than $20. So she's asking her to spend no more than $20. That's going to come up here in a second. So let's underline what's important here. We got $5 for the popcorn, represented by the P, and we have candy, boxes of candy, for $2, represented by the C. So let's identify that. Now let's graph and write an equation that represents all the possible number of combinations of popcorn and candy she is able to buy. Well, first of all, let's think about what her limit is. What's her limit? Now, don't be fooled by the distractor, right? $50. You know, if you got in a $50 bill, you may be fooled by the distraction. She said no more than 20, but you're thinking, I got $50. Don't do that. Don't get in trouble. All right, so where our limit is no more than $20. So I'm going to think of an equation here. I'm going to put $20 at the end of this equation. I'm going to write some stuff here. So first thing we think of is we're talking about some amount of money, right? And we said it can be no more than $20. Well, can it be equal to $20? If you had this $20, could you make an argument to say it could be equal to $20? Well, absolutely. So in drawing my inequality, I'm going to go ahead and say, well, it can be equal to $20. Can it be less than $20? Absolutely, it can be less than $20. So everything over here is less than or equal to 20. Well, what am I buying? What are the possible things I can buy? I can buy popcorn, and we can buy candy. So it's a combination of these two have to equal $20 or less. So how much is a popcorn, since we're talking about cost here? Well, popcorn costs $5 each. So $5 for every popcorn. So if I were to make this an expression, this would be $5 times the number of popcorn, because P stands for each bag. So 1 times 5 is $5. 2 times 5 is $10. So this is represented correctly. What about my candy? Well, my candy is $2. So now I have 5P plus 2P. So this combination right here tells me the total cost of popcorn and candy that I can buy. And this equation, or this inequality, is telling me what I can get for $20 or less. So this is very important as we go forward. So did we write an equation? Yep, we got an equation. Well, let's see if we can graph it. So in trying to graph it, it helps to think of some points. So let me get some points. And let's start with the X and Y intercepts. In other words, for this situation, let's think about what if all we got were popcorn. All right, so let's think of what if C was 0. That's what I want to think of. What if C was 0? I got no candy. All I wanted was popcorn. Well, if all I got was popcorn, let's imagine I could scratch this piece out, because 0 times 2 is 0. So now what do we have? 5 times how many popcorns can I buy to get $20? What's the most that I can get? Well, 5 times 4 would give me that. So I know that when C is 0, I can do 4 popcorns. Well, what if I did the opposite? What if I got no popcorn and all I wanted was candy? So no popcorn, this would be 0 here. So let's ignore this part. Let's pretend that's not there, because 5 times 0 would be 0. Now I just have $2 for every box of candy. Well, how many boxes of candy can I buy to get up to $20? Well, 2 times 10, good. 2 times 10 would give me 20, so I can buy 10 boxes of candy. Well, these 2 points are enough in order to identify a graph. Oftentimes, this equation is all they're looking for, but we're going to take this a step further to make sure we know what it looks like on the graph. So, how convenient. There's a graph right here. So let's plot these 2 points and see if we can get an idea of what this graph will look like. So first of all, let's plot this point 0, 4. 0, 4. So C is my X on my X-axis and P is my Y. So 0, I'm not going to move it all on the X-axis, but I'm going to go up to 4. So now I've plotted my first point, and my second point, 10, 0, 10, 0 will be here. All right, when I connect these 2 points, I get a line, and I made that line solid line. Why? Because it says it can be equal. So everything on this line qualifies as well. So this point will qualify. Everything on this line. Notice I didn't pick this point because that's a fraction, and I can't buy a piece of bag of popcorn. I can't buy half a bag of popcorn. But anything on that line qualifies, and anything above or below, well, we want to be less than $20. So all these things less than 20 will qualify. So I could shade all this in. So imagine this is all shaded. There is all shaded. So what that's saying, that all the points here will qualify. So if I were to identify some points like right here, this is saying that we could buy 1 bag of popcorn and 1 bag of candy, 1 box of candy and 3 popcorn. So this is 1, 3. Here's another one. I could buy 2 candies and 2 popcorns, 3 candies and 1 popcorn. So all these are possible combinations in order to stay within that $20. Now, if I bought this one, this will maximize the money I have, right? Because I'm right there on the line saying equal to 5 bags of boxes of candy and 2 popcorn. So 5 times 2 is 10. Then 2 times this 5 will be 10. So 10 and 10 will give me that 20. So as well as these intercepts that we identified earlier. So this is how you want to think about this inequality in these verbal descriptions. So let's go to our next problem. See if you can work this one by yourself. Mr. Lopez. I will pause it, read it, see if you can answer this before we get started. All right, so Mr. Lopez wants to take his class on a field trip, and he's trying to figure out how many students and chaperone adults he can take. He checked the prices to learn that each adult ticket, so the adult tickets, this is an important part, A, costs $10, and each child ticket, we're going to say N for niños, costs $5. $5, too many dollar signs there. He only has a budget of $120, so that's important. Let's graph and write an equation that represents all the possible number of combination of adult and children he can take on the trip. So what's all the possible combinations? How many children and adults can he take to meet this budget of $120 or less, right? Because he has a budget, so that's what we're thinking of. He can spend up to $120, but no more than. So the first thing I need to think of is an equation. Well, I know that he has a budget of $120. I'm going to start there. It's okay if we equal 120. That's all right. That's part of our budget. But we cannot go over. Whatever we put on this side has to be less than or equal to 120. Well, I know that each adult is $10. So 10 for every adult. 10 times A gives us the cost of all the adult tickets, plus the cost of all the niños, the children, is $5. So we got 5 times the number of children that can come. So this is representing the total cost for everyone coming on the trip. Now, we got our equation. Fantastic. High five, fist bump everywhere. And honestly, this part is the main part for this TEK. Is being able to take a verbal description like this and transform it into an equation or an inequality like this that represents all the possible combinations you can get. Now, I want to go another step again and graph all the possibilities because it's really cool to see it and visualize it. So when I do that, here's what I need to start with. I like to start with the X and Y intercepts, or the extremes, right? So what if we had no kids come? I know that sounds strange, just all the adults go. So what if we had no kids come? How many adults could we take? So let's assume that we had 0 right here. 5 times 0, this thing is gone. This is just 0. 10 times what could give us 120? We could spend the total amount. Well, that'll give us 12 adults that could go. 12 times 10 would give us 120. Well, if I had no adults go, like no adults, I don't know how the kids got there. They drove themselves, they rode the bike. I don't know. This is crazy. But in order to draw this graph, I'm going to assume that no adults ridden so we can get the extreme case and get the intercept here. So if no adults go, that'd be 0, 8 times 0. I'm sorry, 10 times 0. Now we have 5 times what gives me 120. Let's think about that. 5 times 20 gives me 100, so I need another 4 to get to 20. So 5, 10, is that 14? So let me double check that. No, it's not 14. Let's see, 120, 5, 2, oh, it's 24. Okay, 10, that's what I meant to say. Come on, you should have told me that. All right, 24. All right, so those are my extremes. So it's easier to graph this now. Pull up my graph. There we go. So now when I graph this, I'm just going to put those points on the graph. 0 for my niños and 12 for my adults. So right here. And 24 and 0 is my other extreme. Then I'm going to draw a line to connect these. And there it is. And I drew a solid line because it is equal to, you can have all those numbers equal. If it were not equal and just less than, how would we change that line? I'm hoping you're saying it a dotted line, right? So we'll put a little kind of a dashed or dotted line to show that you can't equal everything on that line. All right, so but in this case we can. So I'm happy about that. All right, so all this space below, since we want less than 120, is what we're interested in. So all of this right here, if I could color it in better, I would, but that's going to have to be sufficient. So any of these combinations right here, 2 children, 8 adults, 4 children, 6 adults, 8 children, 2 adults, all these combinations that are in here would work. So you can look at any of these points. You can look at any of these points on the line that will maximize that $120. So 12 kids and 6 adults. You could do 16 and 4. So this would be great conversation pieces that Mr. Lopez could have with his other teachers or principals and say, look at what all we can do. How many adults do we have? Well, if we only have 6 adults, we could take 12 kids. 6 adults right here would give us 12 kids. So you can have a great conversation instead of looking at just the inequality and trying to keep plugging in those numbers. So how fantastic is that? All right, given the graph below, let's go backwards this time. I'm going to give you the graph and I want you to come up with the equation. So what's the inequality here for this situation? So writing the equation and description that could represent all the possible number of combination of baseball caps and t-shirts. So how do we start here? I would start here by trying to draw the inequality. So what would be the inequality that represents this? Well, first, to draw an equation, the easiest form to use is slope-intercept. If I can find the slope and the y-intercept, then I can start getting that equation going. And I can already see that my y-intercept is 25 and my slope is, let's see, we're going from 25 to 20 after 10. So you could actually take the extremes, 25 to 50. So let me just do these 2 points. So I'm going to take 2 points to find the slope. So it looks like we went down 5, down 5, down 5 right here. So we went down 5 every time we went over 10. So we're going down 5 t-shirts. We're going to make that I'll leave the units alone for now. So with -1/2. So if I'm going to write an equation, it's going to be y equals, actually I'm not going to do y because we're looking at t. So we're going to say t equals, because that's representing our y, 1/2 or -1/2 actually, -1/2 b, instead of x, we're going to have b plus 25 because that's our y-intercept. So there we go. All right, we did it. Now, unfortunately, most of the times when we're talking about inequalities and graphs like this, it's going to be in standard form. So let's get this in standard form. Standard form is going to be in the ax plus by equals c. So I need to get this b on this other side. So in order to do that, I can add 1/2. b to both sides. And that gives me 1/2 b plus t equals 25. Now, another thing for standard form is you can't have a fraction for that coefficient. So I need to multiply by something to change that. Well, in order to change that, I can multiply by 2. Multiplying by 2 on both sides. Well, multiplying by 2 here, 2 times 1/2 is just 1, because these 2's are going to cross out and just leave me with b. And this is going to become 2t equals 50. So that's one scenario right there. So we have an inequality, or you know what, I said equals, but this is obviously less than, isn't it? So I should have been saying it's going to be less than or equal to this whole time, because I can see everything below is shaded in. So less than or equal to. So the situation we could have thought of, let me rewrite this so this is not in our way. So I said b plus 2t less than or equal to 50. Let me erase that and do that again. So b plus 2t is less than or equal to 50. All right, so Ronald, you could say, think of it this way. Ronald's trying to raise money. He's going on a school trip. He needs to raise at least $500. So instead of 50, we can multiply all this by 10. So multiplying all this by 10. So now it's 10b. This is 20t less than or equal to 500. Let's see if that matches. He needs to raise at least 500. In order to do so, he's selling baseball caps for $10 each. Baseball caps for $10 each and t-shirts for $20 each. So this situation could match this graph. Or you could have used the $1 right here and $2. It is still the same graph, but this makes more sense than selling them for $1 and $2. So that's how you can represent that, and that's how we use inequalities when we have verbals. All right, how does this show up on the star? So I want to do a couple of problems and close out here. Baseball fans can buy tickets for seats in the lower deck or upper deck of the stadium. Tickets for the lower deck cost $42 each. So $42 each. I already know that this is going to be some kind of setup here. $42 each. For the lower deck tickets is $40. Ticket prices for the upper deck are 75% of the cost of the tickets for the lower deck. So the upper deck is 75%. Upper deck is 75% of whatever this is. Now, does that mean the upper deck is going to be more expensive or less expensive? Well, if you understand percentages, you understand that 100% would be exactly 42. So anything less than 100% is going to make that a smaller number. But let's keep reading. Which inequality best represents all the combinations x? X is what? The lower deck. And y is the what? Upper deck. That someone can buy for no more than 800. No more. That's an important part. So let's start there actually. No more than. Can you be equal to $800? Sure. It just can't be no more than. So I'm looking for those who have equals. Equals, everything. Oh, you know what? This doesn't have equals. I can already say this is not going to be the right answer because it has to include equals. It can be equal to just no more than. So I'm already at 50% before I've done any other work to it. All right, now we need to, all of them are 800. So now we're thinking about what's the lower deck cost. It's $42, and that is represented with my X. So these both have 42X, so that doesn't help me at all. But look at the upper deck cost, $56 or $31. Well, remember what I said earlier? It's 75%. The upper deck is 75% of 42. So what is 75% of 42? So we could take out our calculators and figure that out, or you can do it by hand. You can actually do 42 times 0.75. And you'll come up with something that's less than what we're getting here. Yeah, I'll go ahead and pull that up now. We'll look at the calculator to show what that is. So if I pull out my calculator and just quickly did that, I will get 42 times 0.75, and we'll see that's 31.5, which is not a surprise to us because look, they only gave us two choices. They only gave us $56, which is more, probably 75% more, or 31, which is less, which makes more sense. If you wanted to be a little bit more advanced, you could have saw that 75% is the same thing as 3/4, and just looked at it that way too. Times 3/4, and went about it multiplying like a fraction. But that's neither here nor there now. So we're going to add the 31.5. So here's the right answer. Obviously, hopefully you saw it early on, but that should be pretty clear. It was kind of tricky them saying 75%, but not really. Once you do the calculations or just think about it, it becomes clear that C and D is obviously not it because it's missing the equals, and that's all you have left. Let's do one more. A student is ordering a flowering arrangement. She can choose any combination of roses and carnations for her flower arrangement, and she does not want to spend more than $30. Nobody's trying to spend more than a certain amount. Now, can she spend $30? Can she equal $30? Absolutely. She can't spend more than that. If roses cost $3 each and carnations cost $2 each, let me underline this stuff. I like to underline as I go through. So we got roses is $3 each, carnations are $2 each, which inequality represents all the possible combinations of X are the roses and Y are the carnations. I should have switched up those colors. So there we go. That way we're sticking with the same colors. All right, so $3 per rose, so that's 3X, and carnations are 2Y. We can do no more than 30. So can we be equal to 30? Yes, but we can't be greater than. It has to be less than 30. So really, that's what we're looking for here. I could have crossed out a couple of answers. It can be. There's no equal sign there, so no, that can't be right. And there's no equal sign here. That can't be right. It has to equal to show all the possible combinations that are no more than 30. But this can be equal 30. And the only ones I have left is they're trying to make sure you connect the 3 with the X correctly and the $2 with the Y. So which is what we've done, and here we go right there. That is it. Write linear inequalities in 2 variables given a table, values, a graph, and a verbal descriptions. As you see, most of the time in the test, they're going to test you on the verbal description, so we spent most time there. Now you know what it can look like on a table, but especially a graph as well. Hey guys, thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I'll see you next lesson.